This video is a review of the basic ideas of kinematics equations learned in our first year physics course. Recall that kinematics is just how we describe the motion of objects, and sometimes we do that with graphs or equations, or once in a while with a motion map, although that's not a big stress in the AP course. This video is really going to focus on the equations that are used to describe the motion of objects. Over here on the left, there is a list of the variables that we generally use to describe the motion of an object. These sometimes change to maybe a y instead of an x for position, or we might use some other subscripts and so forth. But these are the most common variables used for describing the motion. The the formulas that we would have used in our first year course, I'm going to go through those very quickly. So acceleration is defined as the change in velocity over time, and this is sometimes rearranged algebraically into v equals v sub 0 plus at. This is a very useful equation when you know something is accelerating, but you don't know anything about where it is or how far it is traveled. Notice there's nothing about x or delta x in the equation. A second equation that we used quite a bit was this one, delta x equals v sub ot plus 1/2 at squared. Notice here what's missing is the final velocity, and so this was very useful for those sorts of situations. We can also use this to set up a general statement of where the object is as a function of time. And if we do know that the object moves with a constant speed, then there's no need to have a formula that has a v sub o and a v. So this is a useful one to use. And that would mean that the acceleration is 0, and we get just kind of a simple delta x equals v times t. And then the third equation we used with kinematics was a combination of the other two. This one eliminates time from the discussion, so it knows there's no t in this equation. So it's very useful for situations where time is difficult or to find, or it's just not known. The formulas on the formula sheet that we use in AP Physics look a little bit different. They specifically put in a subscript of x in various spots. That is really just to remind us that these formulas are only valid when an object is moving along a straight line. Okay, so it has to have a consistent direction of motion. If it's moving in the x direction, then its velocity and its position and its acceleration all have to point along that same direction. So this is not useful for circular motion, and it doesn't fully explain the ideas of projectile motion. Now, you don't have to write the formulas this way. This is just the way they will show up on the formula sheet. You are welcome to write the formulas in the way that you're more accustomed to. And then finally, just a reminder of what we are typically doing with kinematics equations, and that is to determine some sort of an unknown value. So one way of approaching this is using something called a guess method. The guess method really is just a summary of what we did last year, just kind of giving it a name or an acronym. So the idea is that as you read through a question, you would decide, oh, what sorts of information have I been given? Then what sorts of information am I asked to find? And so just kind of going through that with this example of a ball bouncing off of a brick wall. If I were to first highlight the givens, I might write down something like this, that v sub o is 28 meters per second in one direction, but because it rebounds, v, the final velocity, would have to be the opposite sign of that. So I could either use negative 28 and positive 12, or I could use positive 28 and negative 12. So the idea here, again, is just to identify what sorts of information you're given. Sometimes it's sort of hidden information. Sometimes, like it might say, an object starts from rest, and so your v sub 0 would be 0. So, but mainly we're looking at the values that are being given. We want to be very aware of what the question's asking us to find. Okay, so that's our acceleration is our unknown here. Now, these steps here, these are kind of optional. Depends on if you see right away a method, a relationship that will work for a question, but these are good strategies to always sort of come back to. The last three steps are what are required for all solutions. You need to include the formula that you are thinking, that you think describes this relationship. So in this case, that would be v equals v sub o plus at. You need to substitute the information, all right? So whether or not you've listed it off in the first place, you need to pull the information from the problem and plug it in, and your unknown will be the variable that you're solving for, and then you would solve for that particular variable. Now, this acceleration I actually wrote as a 1,000. I think it's actually supposed to be a negative 1,000 if I go through and do the algebra correctly, and that's because I was sort of thinking ahead to what the problem was asking for, and that is that it wants the magnitude. And so even though the acceleration does come out officially as negative 1,000, the magnitude of that is just the positive value. The problem doesn't really tell me which way positive or negative is, and so the best answer is to just simply say that the value of the acceleration is 1,000 meters per second squared. It's a nice idea to box your answer so that it's very clear to the reader, the grader, that what your final answer is. All right, so just a quick summary of some of the things to avoid. Don't just think of the formula, okay? Make sure you actually write it down. Very important part of problem solving. Don't do something with the numbers in your head and then plug them in. Okay, put in the actual values that are given. You don't need to write every single step of your algebra. You can notice in my example here, I didn't write out that I subtracted 28 and I divided by 0.04. If you can do the algebra without writing down every step, please do so. And then just, again, make sure that your answer is very clear. Make sure you've included units. And again, all solutions should have a minimum of 3 steps: the equation in terms of variables, the substitution of the given information, and then a solution with units, sometimes a description.